Alright guys, I want to show you how to solve a system of equations in 3 variables. So before doing this, I might recommend that you practice solving systems of equations in 2 variables a bunch so that you get the idea behind it, although you could fast forward a little bit and watch me solve a system of equations in 2 variables when we get to step 3. So anyway, I wrote out some steps so that this is a little bit easier to follow. We will talk about these steps again in class, but we're going to be dealing with a system of equation in 3 variables, x, y, and z. So I say that the first step is to choose a pair of equations and just eliminate the z. That'll give you an equation in x and y, something that you're very used to using. And then step 2, choose just a different set of equations and eliminate the variable again. Now you have 2 equations in 2 variables, so you can solve the resulting system of equations in 2 variables. And then to solve for the third, you just plug those 2 values, x and y, into one of the original equations. Of course, the 5th step, highly recommended, although not required, is to check. So let's go through an example. Let's say, for example, I have x minus y plus z equal to -7. Let's take 4x plus 2y minus z equal to 5. And then let's also take 2x, -2x, plus 4y equal to, minus z equal to 33. So that is -2x plus 4y. All right, so you're supposed to choose a pair and eliminate the z's. If I'm just looking at pairs right away, I see equation 1 and equation 2 are both ready for the z's to be eliminated already. So meaning I can take equation 1 and I can add equation 2 to it. And what happens? I have x minus y plus z equal to -7, 4x plus 2y minus z equal to 5, so that when I add these two vertically, the z's eliminate. Now be very careful. Small mistakes will ruin this entire problem. So just go piece by piece. X plus 4x gives you 5x. A -y plus 2y is positive y. And then -7 plus 5 is -2. Now for step 2, we're supposed to choose a different pair. We chose equation 1 and equation 2 before, so I just have to choose a different pair. What are my options? I can take equation 1 and equation 3, or I can take equation 2 and equation 3. I'm going to take equation 1 and equation 3 and see if you can figure out why. Equation 1 is still x minus y plus z equal to -7. Equation 3 is -2x plus 4y minus z equal to 33. If you didn't guess it, the reason why I chose to use equation 1 and equation 3 is because the z's eliminate when I add vertically again. Notice if I chose 2 and 3, the z's aren't quite ready to eliminate because they're both negative. I'd have to make them opposites in order for them to eliminate, so there's just one extra step that I'd have to do. So equation 1 and equation 3 are already ready to go. Let's just use those. X minus 2x gives me -x. -y plus 4y is positive 3y. And then -7 plus 33 is positive 26. So I chose 2 different pairs of equations. I eliminated the z's twice, and now I have a different set of equations in 2 variables. Some people will call this equation 4, some people will call this equation 5. I don't want you to get lost in the numbering. The idea is you have 2 equations in 2 variables. If you take 5x plus y equal to -2 and -x plus 3y equal to 26, this looks like something that we solved in chapter 4.1. So you can totally solve the system of equations in 2 variables. Maybe I'll copy it and take it to the next page so that we can solve that one. All right, 5x plus y equal to negative 2, negative x plus 3y equal to 26. This is a system of equations in two variables. If I can find x and y here, then I can go back to one of the originals and plug them in to solve for z. So it's up to you. Remember, you can eliminate x's or y's. If I want to eliminate the x's, I would multiply the whole second equation by 5. If I want to eliminate the y's, I'd multiply the first equation by negative 3. I think I'll do that. I don't want to multiply 26 times 5. So I'll just take 5x plus y equal to negative 2 and multiply that whole equation by negative 3. That gives me negative 15x minus 3y equal to positive 6. And then bringing down the fifth equation, the equation that I didn't do anything to, I still have negative x plus 3y equal to 26. Now the y's are ready to be eliminated. So that I end up with negative 16x equal to 32. Well, now I just got to divide both sides by negative 16 to get x equals negative 2. Again, this is just a system of equations in two variables, so I can plug that into either of the equations. I'll just deal with 5x plus y equal to negative 2 and plug that negative 2 in for x. 5 times negative 2 plus y should equal negative 2. Well, that means that negative 10 plus y should equal negative 2. Or if I add the 10 over to the other side, I get y equals 8. Remember, this was a system of equations in three variables. I have x equal to negative 2, y equal to 8. If I go back to the system of equations in three variables, these are the equations that we're trying to solve. But what I currently have is x equal to negative 2, y equal to 8. So I'll rewrite that so that we're clear that x equals negative 2, y equals 8. Oh no, something happened to my lettering here. Maybe I didn't copy it all. Let me go back. Let's try this again. All right, there we go. All right, so again, x equals negative 2 and y equals 8. That's what we have so far. We got that from solving the system of equations in two variables with equation 4 and equation 5. But this is what really matters, that we're solving a system of equations in three variables. So it's up to you. You can use any one of these equations to solve for z. I'll just probably use equation 1. So I can take x minus y plus z equal to negative 7, knowing that x should be equal to negative 2 and that y should be equal to 8. So what does that give me? Negative 2 minus 8 is negative 10 plus z equals negative 7. If I add the 10 over, I get z equals 3. That means then that my solution is the ordered triple, negative 2, 8, and 3. I can check pretty quickly mentally. Negative 2 minus 8 is negative 10, and then plus 3 is negative 7. Or if negative 2 times 4 is negative 8, plus 2 times 8, which is 16. Negative 8 plus 16 is positive 8, so that when I subtract 3, I do get 5. And if I plug in negative 2, 8, and 3, I get positive 4 plus 32, which is 36, minus 3 gives me 33. So I see that it works in all three equations. I'm fine checking. You can write out the check, of course, if you're going to check. I highly recommend it. So let me write up a new problem and show you what is the case if the z's aren't ready to be eliminated. All right, let's solve the equation x plus y plus z equal to positive 6. 3x minus y minus z equal to 2, and 2x minus 4y minus 3z equal to negative 32. All right, again, equation 1 and equation 2, those x's are ready to be eliminated. I'm sorry, those z's are ready to be eliminated already, so let's just eliminate them. If I take equation 1 and I add equation 2 to it, then x plus y plus z should equal 6. 3x minus y minus z should equal 2. When I add vertically, something nice really happens. What I end up with is not only the z's eliminating, but the y's also eliminating, so that 4x equals 8. If I divide both sides by 4, I get x equals 2, which is a great start. But I can't just plug that in and solve for y or z because I don't have another equation in 2 variables. So I still got to take a different pair and eliminate z again. In this case, there's no other pair that's ready to be eliminated. So I'm going to take equation 1 and equation 3 again, but I got to do some work so that the variables are ready to be eliminated. I have x plus y plus z equal to 6. If I want to eliminate the z's from equation 3, then I should multiply the whole equation 1 by negative 3. That gives me negative 3x minus 3y minus 3z equal to negative 18. Now, when I add equation 1 to equation 3, the z's will eliminate again. I have negative 3x minus 3y minus 3z equal to negative 18. And then I also have 2x minus 4y minus 3z equal to negative 32. So that what happens in this case is that the y's don't eliminate again, just the, oh no, the z's don't even eliminate because I multiplied by a negative 3. I should have multiplied by a positive 3 to keep the signs opposite. Positive 3, positive 3y, positive 3z, and positive 18. So that when I add vertically, the z's eliminate. Right, I just want them to be opposite. So if I have a negative 3z already, I should have multiplied by a positive 3 so that I end up with a positive 3z. The z's eliminate. What does that give me this time? That gives me 5x minus y equal to negative 32 minus 18 is 14, negative 14. Now, let me just tell you that this is still a system of equations in 2 variables. I have x equal to 2 already, and I have 5x minus y equal to negative 14. So if the first one's already solved, I can just plug that value into the second equation and solve this one right away. Let me start a new page for that. Let me copy this guy. Because if x equals 2 and the equation that I want to solve is 5x minus y equal to negative 4, then I can just let x be equal to 2 and solve this equation right away. So there's no real work to solve the system of equations in 2 variables in this case. 10 minus y should equal negative 4. So that if I subtract 10, negative y equals negative 14. And then if I divide both sides by negative 1, I get y equals 14. Positive 14. Oops, I think I lost the 1 that we had before. Let me go back to the previous page. It was supposed to be 5x minus y equal to 14. So this really should have been a 14 when I copied it. That means that this problem should have been a 14. So that when I add, I don't get 14, I get negative 24 for negative y. I subtract the 10 over, I get negative 24, so that y equals positive 24. Let me just erase that and start over. Sorry about that. Negative y equals negative 24, so that y equals 24. So what I have so far is that x equals 2 and y equals positive 24. I should go back to one of the original equations and substitute those values in again. So let me just take all three of these. Over to this new page. I might as well just substitute into equation 1 again. It's not only the simplest, but there's no negative, so I'm less likely to make a mistake. I'll take x plus y plus z equal to 6. Let x equal 2. Let y equal to 24. And solve for z. So that 30 plus z equals 6. Oh man, I mean 26 plus 6. 26 plus z equals 6. So that when I subtract 26, z equals negative 20. All right, so then my answer is the order triple, 2, 24, negative 20, and I can check to make sure it works. Again, these problems are a little bit long, and there are a lot of small mistakes that can mess everything up. So just be careful as you go step by step. You notice in the second problem I made a few mistakes, but luckily I caught them before we got too deep into it. So try it out. There's one problem just like this one on Math Excel. You can give it a shot for an extra quiz point. All right, see you guys in class.